Howdy y'all, it's Airgun Sunday. We're back with the 850 Hammerli with part 2 of the CO2 test. It is January 2nd, 2022. Yesterday it hit 82 degrees. Today's high is supposed to be 42. Right now it's 30. So I was hoping for a day of about 45 to do this, but 30's good too. This should really show up in a test being this cold. I've already got the thermometer hooked up. It's saying it's about 33. So we're going to get things set up here so I don't have to sit out here in this cold too long. The cold's not too bad, but we've got a good 15-mile-an-hour breeze with probably 20 mile-an-hour gust. So that wind will cut right through you. So let me get the camera set up and we'll start doing some shooting. Okay, my target cam doesn't like this cold weather, I guess. So we'll just take a picture of the target once we're done. All right, temperature is 31.2. $563. It didn't even hit the target, it dropped so low. $575. I'm gonna aim at the very top of the target and see if it will hit the target. There we go. 557. I don't think it read that one. I keep forgetting about this auto safety. I think it only read 6 out of the 8 shots. I got another magazine already loaded, so we're going for that. I'm gonna aim probably 3 or 4 inches above the target. I don't know where it's hitting. We're definitely seeing what the effects of cold does to it. I see my thermometer turned off, so let me turn it back on. It's showing 29.8. Yeah, it's pretty bad. 488. All right. What I'm going to do is take the gun back inside to let it warm up. And then we'll come back out here and we'll shoot another magazine across the crony and see by warming it up if temperatures come back up. All right. Temperature's dropping fast again. I had it at 65 from in the house. Let's see what we got. I'm in dead center. Oh yeah. Stupid safety. It's starting to drop again already. Not even hitting the target. I put 2 or 3 on the target. Now it's below the target. Let me aim up high again. I don't know where that went. Well, it hit target, but I don't know where. Or it hit my pellet stop anyway. I think it's hitting way down low. This wind ain't helping none. These slow light pellets. Yeah. All right. We'll go inside, get warmed up again, and do a little talking about this. All right, before I take it down, I wanted to show y'all how I had it hooked up. Basically, just got the thermostat or thermometer probe taped on with a piece of Scotch tape. How we got it done, and we were shooting at 30 yards. All right, here's the target. You can see it's pretty much everywhere. This wind barely blowing them around. First couple shots came out this morning. It wasn't even hitting the target. I raised up to here, and I think I hit a couple here. Then I went up to here and got a couple. When I came back in from the or came back out after letting it warm up. I aimed right there and hit right there. I think I hit one over here, and that's all. Air started dropping so low again. Couldn't hit nothing, so looks like I might have hit one up here. But this wind really blowing those light pellets around, especially running so slow velocity. So, well, there's the target.
Okay, so this here is the basic pre-charged pneumatic CO2 type air rifles. This is about as basic as you can get. You have a tube. The valve is pinned in here. And then you got a hammer in here with the trigger holding it back. And then here's your end cap for the spring. So when you cock it, it holds the spring good and tight. You got your valve. PCP would have this screwed in on the end of it with your fill port. If you're running CO2, you would have a valve that would have a seal on the front. Same here, you would screw in and seal up on the face. So what happens is obviously you cock it, and when you shoot it, the hammer comes up, hits the valve, and opens it. It opens it for a certain amount of time. Now, let me get this out of the way here. What happens is when you open this up here, this is the poppet and the valve body, and it goes in there and it seats right there. Now, this measures about 430. So if you take the square inch of this, which is 0.145, and times it by the pressure, at 70 degrees, and we look at the CO2 chart and find the pressure and multiply it by that, you have 123 pounds of pressure pushing this shut. So at 90 degrees, you got 159 pounds of pressure pushing that shut. Whereas you get down to 40, you've only got 82 pounds pushing it shut. So this morning's shooting, we was down at 30 degrees, so we probably didn't have less than that. I don't even know if the chart shows 30 degrees. Let me look. Yes, it does. It shows 491 PSI. So I just had my calculator here. Where'd it go? Oh, there it is. 0.415 times 491. That's only 71 pounds of pressure holding that valve closed. So this is the thing that, like my very first air gun I ever built, I miscalculated the spring and the because you got to have the spring tension, you know, and how much pressure power it's got, how much your hammer weighs, so it can make enough kinetic energy to open this valve. I miscalculated all that on my very first one, and what it would do, it would hit the valve, but the pressure pushing it back would actually push this hammer back enough to where the spring would have enough tension to slam it forward again, and I'd get 3 bursts of boom, 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 boom. So I had to recalculate all that. So now this isn't exactly the same as the 850 Hammerli, but it's real similar. Basic design is the same. The spring in that Hammerli didn't have enough force at the 90, 100 temperature to actually open that valve. We had to wait for it to come down. I think it started opening it up at about 90 degrees, somewhere in there. But at that 100 degrees, it wouldn't even open it. There's ways of getting around that. One is you can obviously see that these two springs are different. This is a heavier spring. It also has a spring guide in it. And that spring guide is so that when you put your end cap on, you can put a screw in here and you can preload that spring up some. That'll give you more energy. But that's how a basic PCP works. So what happened to us on the first video when we went over 90 degrees and the at 90 degrees, well, they don't even show it on here. At 80 degrees, you're pushing 969 psi on the CO2. So at 90 and 106, we were pushing way higher than that, which the the hammer spring in the 850 couldn't open that valve. That's what happened. Now, since we went all the way down today to 30 degrees and way lower, what did I say, 70 something pounds of pressure pushing that valve shut, and then the actual pressure not being able to push that pellet fast enough, we were shooting way below the target. But that's the basics of a PCP and how it works. And that's, by using this chart, you can understand how much more energy you have to hit. And this is the whole reason why CO2 is not a great power energy, how would I say that again? A great source to power a PCP because of its temperature sensitivity. So this is what I've been trying to do on this whole series here, on these two videos explaining CO2. Okay, so this is what we came up with. At our control temperature of 75, we averaged 743 feet per second with a standard deviation of 2. When we went to 30 degrees outside, we averaged 543 feet per second. The high was 575, the low was 488. That's an 87 degree extreme spread with a standard deviation of 25. You can definitely tell it's affecting that CO2. And then when we came back out with it, and it was around 50 degrees, we had a high of 662, a 646 low, averaged 653, extreme spread of 16 with a standard deviation of 5. Now you can obviously see how much, when it starts warming up, it starts getting a little more consistent. So yeah, CO2, best shot in the 70 to 80 degree weather. Maybe 65, depends on where you're at, I guess, maybe, I don't know, but definitely 75 degrees, I believe, is what the chart says is normal. if I can remember here on what it is. But I believe that's what they had on there, was around in the mid 70s is what it's best suited to run at. So, and that our controls kind of showed that.
All right. I hope y'all enjoyed this little two-part series using my 850 and learning a little bit about CO2. I hope I explained it okay. I'm not the greatest explainer, not the greatest teacher, but trying to translate what I got in my head and things like that. A little bit of math work, but I enjoyed doing it, other than I'm a little cold. But other than that, it's pretty good. I like shooting. Anytime I get out to shoot, I have fun. So wanted to thank everybody for watching this video.